Hello shape enthusiasts, and welcome back to another episode in our MAM build series. What is a MAM? It is a make anything machine where you give it some shapes, you give it some colors, and it will use its brain to figure out what shape that you want to make and just do it for you automatically. It will build every single milestone random shape that the game can throw at you. In the previous episode, we finished off our painting array and did some cleanup on our base. And now this is what our current MAM looks like. Our MAM is able to build colored single layer shapes at the moment. It starts off with a belt of shapes. It puts it through these quarter cutters to turn them into 4 belts of each shape. Then it goes through these shape selectors, which will select the correct quarter for each quarter. Then it'll take those quarters and put it through this dynamic painting array to select the color for each quarter. Then it'll output the final shape over into this recombinator, which will use swappers to merge them back together and form our final shape. We wanted to create the next shape in the milestone, which is actually a stacked shape, right? But to do stacking, we basically need a whole copy of this entire thing that we built. But we're not complete yet, because shapes don't just have color. They also can have crystals and pins. So before we do any sort of copying of what we have to 4 layers, we need to accommodate for those factors. I was going to do an episode on pinning and crystallizing, but unfortunately, the new update just came out, update 0.08, and I'm on that update now this episode, and that introduces a whole bunch of new quality of life features, but one in particular in the circuitry section under flow control, we now have a pipe gate. So if you watched my painter video, you'll notice I said in there, wouldn't it be nice if we were able to, instead of having these 7 static painters and then routing our shape through it like this, wouldn't it be so much nicer to be able to control our pipes dynamically and just pick the single color into a single painter and put our shape through that? Well, now we can. So let's figure out how that works, and we will rebuild our painting array. This will be like a special bonus episode or something, but we definitely have to do that. It will allow us to collapse this section into a much smaller form factor, I believe. I don't know. But let's see how that all works. So I'm going to definitely need a big platform, because whatever I build is going to need to input all 8 belts of color, or 7 belts of color, I should say, do some logic, and then spit out a singular belt of the correct color that we want. So how will that work? So let's see. Let's pipe everything in, and then I'll just grab a couple of pipes and do some testing. So if we just grab a pipe of this belt, we'll use magenta for our example, I guess. Oops, that's not the space. That's not a pipe. It's a space belt. So we'll grab 4 of these. And remember, you can merge 4 belts worth, 4 launches worth into one belt, because launches launch at 1800 and belts carry 7200. So we definitely need to merge them all together, whatever we're doing. Let's see what the pipe gate does. It gates fluid based on logical signals, 1 per pipe, 1 per fluid launcher, sorry, and it does 1800. So you need 4, 1 for each one of these, right? But we can do that, like we can split off this pipe when we merge it, depending on where we want to do all this. I have some ideas in my head, but we'll see where we get by designing and testing. So basically this needs to then, wherever this goes, it needs to then split back off into its 4 constituent pipes like this. Then at the end of these, there needs to be a one of these pipe gates. So a pipe gate takes a liquid in and outputs a liquid, and then it also takes in a signal. So we can pretty much assume how this works. If this is any more complicated than what I have in my head, I'll be very surprised. So if we get a signal producer and tell it magenta, I'm assuming that will just let the magenta in. Is that right? Color M. And then we might need to add some more pipe to see that happening. Okay, so that's letting the pipe through. We'll need to build a fluid tank to drain it so that when we change the color, we can see it stopping, right? So if we do that and we configure that to be, let's say, color white, what will happen? Nothing. What? Did I build my fluid gate backwards? Oh yeah, I built my fluid tank backwards. There we go. All right, then the magenta drains out of the pipe and blocks it because it's not the color that it's receiving the signal of. Makes perfect sense. Exactly how I thought this would work. So how can we design something that will achieve the result we want, which is filter these 7 colors and only give us the correct color out? So let's just assume this is our brain. and we want this particular color. Well, we're going to need this sort of setup for every single one of these inputs, right? So it's going to need some space for signal. So let's just drag this out a little bit. In fact, I'll just redo this piping. It's definitely going to need at least one space. I'll try to do it in the smallest form factor possible. Then it's going to need to go through these pipe gates like such. Then I guess all of these can just pipe out together, right? And then it can go into a fluid gate. Yeah, that's pretty much the whole design. But we do need some way to get the signal into here. To do that, something's going to need to launch, and either I can launch the signal or I can launch the liquid. Let's try launching the liquid route first, and then we'll see where that gets us. So if instead I launch, wow, I got the perfect spacing, amazing. So if I launch the liquid in, that gives me plenty of room for signaling stuff. So let's just put some signals in, and then we can see where that gets us. Doing a little bit of design, try to make it as compact as possible because space is always valuable. So it'll be something like that, right? Can we do better? Well, we can merge some of these signals. So if we just go like that, then can these merge? And then we can have slightly less wiring. Can these merge? I believe they can. Then we can have some slightly less wiring, just like that. Let's have a look. This blank space in the middle doesn't seem necessary, does it? So we can collapse in like that. Yeah, that works. I think that's can we go better? Can we get this any smaller? Not without the launches. We definitely need launches because, as you saw before, there needs to be some sort of space. I think we go with this design. Won't mess around with it too much. I think my episodes for this are getting a bit long, so I will try to make it as condensed as possible. So now we have this. How do we make this work for multiple fluids? Let's have a look. So what if we had another one of these, right? Let's just do it for the blue since I have space on that side. Let's get the signal for testing purposes. Let's just bring the signal from one source like that. Okay, okay, so they're both getting a white signal and they're both going no, right? But what if we give it now a blue signal, color B? Yeah, so the blue's going, the magenta's stopped. So whatever comes out of this piping system can just be all merged into one pipe, right? And that's our pipe out, basically, right? Does that work? Let's have a look. Let's chuck a fluid tank in and test if it works with 2. If it works with 2, we can extend the design to all 7 colors very easily. So now let's switch this blue to magenta. Color M. Oh, it worked. Look at that. Amazing. So that's exactly the functionality I need, and that will just disappear the blue and start the magenta. Perfect. So that's it. That's our design, guys. We just need to somehow extend this design to all of this. So I'm just going to delete the blue for now. So whatever we do for one, we're just going to do for all of these. But what are we going to do for the one? I'm thinking, let's just, where can we build? Well, we need 7 of these, but where can we build them? We can build them anywhere. We have a gigantic platform. But why don't we build them near where the colors come in? That makes a lot of sense to me. Let's just take only the stuff that we need and then delete the rest. And then we can just put it right on the color. Does that work? No, I need one space at least. We don't even need to merge the pipes. They can just pipe directly into where they need to go like that. No confusion at all with fluid dynamics. And that's it. Is this gonna be a lot simpler than I had in my head? Do I even need to explain anything? Oh wait, that doesn't fit. All right, we'll deal with the corners later. But they can go anywhere, right? Like I can just put one, say like here. Leave 4 tiles of space for belting. These can mingle, and then we can transport and resplit. That's easy. Just like that. Is that working? Why does that look wrong? I think I did it with the launching part. Yeah, now that's working. So if I take a copy of this, can I take that to the other side? Like that. Yep, that's working. All 7 are in. Now we just need to do wiring. Do I have a signal somewhere? Well, where are we going to put our brain? I don't know. Let's have a think. I don't know where we're going to put it, but it doesn't matter, right? Let's just put it down here. It's so arbitrary. Like, let's say our brain is over here. Let us now take this signal and route it everywhere. Let's do it with a colored signal so I can see what's going on. Let's say I want color red. Yep, it's blocking all of these, and then it needs to go somewhere. Up there, where's the closest way to go? Up there. Let's route something like that. Yup, I'm liking that. This one can do something similar on this side. So far so good, no issues. Why have I got this space so far back? Why don't I line these up actually? Why don't I just bring this back like 2 tiles and line it up? Why don't I bring it back like this and line it up perfectly? Oh god. What am I doing? What am I doing, guys? Why am I bothering with little aesthetic changes like this? I don't know. Seems so pointless, right? That works, doesn't it? Before I do anything. Let's do the same thing on the other side. Something's weird going on with my shift click and right click. Not doing what I want it to do. Let's put that there and we'll give it a shift F, and I believe it's on this line. Yep. We'll grab our wire and we'll wire it in like that, and then we'll just go up. That's nice and clean. I think that's nice and clean, guys. Don't you think that's nice and clean? And then we can do the outputting. We just need to merge all these outputs. Simple. We can do something like that. Why is it doing weird piping? Right? I think we could just like literally merge all the outputs like this with no issues. Pipes seem to sort themselves out very cleverly. Like literally, if I just join the pipes literally anywhere, it should just be fine. We'll test it. We'll test it all, guys. It's alright. You're allowed to make mistakes in this game. You don't need to be perfect first time every time. And then where do we go out? We can go out from like here, or we can just go like out from the middle like this. And then remember, this is a full 7200 liter thing, so we need to split it back out. And that's it. Let's build ourselves a little platform just to test whether this works. Oh wait, what am I doing? I need to merge these. Yup, like that. And we need a fluid tank to get rid of the contents. The fluid tank kind of works like a bin, but it's not infinite, I guess. But yeah, red is going through. What happens if I change the color? Let's make this something we haven't done before. Cyan. There we go. Changes. Switched. This is exactly the design that I want. Change it one more time. Color blue. Takes a second, but there you go. 7 in, 1 out. Just like that, guys. Very simple design. I feel like there's a big waste of space in here, but I don't think there's another platform that has like this many inputs into one platform, unless you split it into sets of multiple smaller platforms. But what's the point in that? I think I'll just stick with this 3x3, and then we'll see where we go from here. I guess we can just duplicate this design up a few levels now, can't we? Oh wait, no, we can't do that yet. Silly. Oops, don't delete it. We haven't even put in our brain yet. So these are going to work for a quarter of a shape, right? Each quarter needs to be able to potentially pick a different color. So we need to get a brain that's similar to like this thing. And we'll just copy it over and we'll pop it somewhere. Where should we put it? Our processing circuit. Keep calling things a brain. I don't know if you guys like that. We'll probably flip it the other way, which is like that. And yeah, this is the top right one. We'll get the color of the top right one out. That's fine. And our top right, what is our shape currently? Oh no, it's crappy, terrible shape. All right, that's fine. We'll just copy that, change our current shape to that, and we'll do some testing. Let's do some testing, guys. Always test your designs. So at the moment, the top right is nothing, and nothing is outputting nothing, which is exactly what I want. Why is this not draining? Ah, this is full. Let's clear the contents of this. There we go. Yeah, so nothing is outputting nothing, which is perfect because it doesn't matter because we're going to have some sort of shape bypass for nothingness. The only one I want to test is gray. So that's this one. So I need 3 rotators to test that. So we'll rotate, 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 just like that. And that is giving me, maybe I should put a display on this to see what color it's trying to do. The display is showing uncolored. And uncolored is giving an active signal, but obviously uncolored doesn't match any of this, so it's also giving nothing. So yeah, this works. This is perfectly fine. It's exactly what I need. So let's take a copy of this and we'll make it work for a 3-level belt, which is what all our space belts are. So let's go there, that there, and then we'll go up 1 level, and then we'll go up 1 level again. We'll clean up this now that we've learnt our lesson about how this gets duplicated a billion times. What? Why can't I delete that? I feel like there's something weird going on with the right click and shifting in this update. You guys feel anything weird going on with like the shift selection and the right clicking? It's something is feeling off. I don't know if it's just me, maybe I'm off, but yeah, Something is definitely feeling off. That is not top right. This is top right. All right, cool. The signal does need to carry up. Can I use a different thing? Oh, no, it's fine. I know what I'm doing now. Even if it is a blank signal, I know this will work. We need to bring the cabling up, the wiring up 2 levels as well. And that should be it. This should be our new dynamic paint selector. So we have a dynamic shape selector. We have a dynamic paint selector. Next step, we need to work this into our actual design because this isn't doing anything besides selecting paint. So paint needs to come in. All right, so I'm pretty confident with this. I think I can delete my old painting build like this. All right, so after deleting that, we will go over here. We'll grab a copy of this. We'll bring it over here somewhere, and then we'll figure out how to incorporate this into our main thing, right? So let's just reconnect all these colors, and then we will figure it out. So we're peeling from up here at the moment. Do we need to peel from up there, or can we peel from here? I don't know, but we'll find out. So let's just continue with what we were doing. Why is this? Oh, this was the old output back out. These are my colors, but I've lost my belts. So let me just, I think I deleted one too many tiles. Was this smart enough? Oh yeah, there's a new feature. You can just do this now, right? Wait, how does this work? Apparently you can just drag, wait, this is not, this is the wrong belt. Apparently you can just drag a belt now through other belts and it just knows how to do the routing. Doesn't seem like the case. Seems dumb to me. What if I, let's test this. What if I delete the entire belt? Will it know how to do the routing? So if I just go, I want my yellow to come from here, down here. Nope, it's super confused. Okay, it doesn't work at all. I think the belts need to be connected for it to be able to do the routing. So I just have to manually do the routing, unfortunately. Yeah, I'll just do one for now and I'll copy it over as necessary. But here's my, oh, getting confused by this outbelting. 1, 2, 3, 4, I need my red as well. So this is where my color's coming in, right? And we might need to shift everything a bit closer because things are super far at the moment. But let's just get it functional first. So, and then we'll worry about form factor in a bit. So we'll give it 1 tile of extra spacing because I don't want everything to be super cramped. I think it can afford 1 tile of extra spacing. So now we have a thing that outputs the desired color based on what you want, right? Something like that. This is going to be top right. Yep. And then top right is currently nothing. So let's build one for top left and then we'll test on that one. Top left is right next door, I believe. So let me just copy over this little craziness over here, I believe. Yep, there we go. We'll copy over this little craziness over here. And we'll make sure it's got one of every color. Great. This will be our top left. There we go. We do need to put a rotation in there somewhere to correctly pick up our top left, and top left is red, and look at that, boom, red comes out. Now red needs to go into a painting array, right? So I'm going to use the painting array from my blueprint design series. Do I have a painter? Yeah, I do have a painter. It's in my blueprint book. So the painter can just go straight here, right? Like that. And then the shape needs to go into a painter. Maybe I want this to be the other way. Like that. The liquid goes in, and then I need a shape to come into this. I'm just going to drag the belt of shapes up. And look, it lines up perfectly somehow. Then, but it's not exactly like that. Because we need some logic to deal with the fact that not every shape directly goes into there. Sometimes they need to bypass. So since we have so much space on the painting platform, let's just do the bypass on here, right? Because we're using the same signal, which is this signal. So maybe we will need to go down here. Oh, damn, I already duplicated this up 3 levels. All right, let me just design this first level part and then we'll copy it up. Because this bypass section, so I'm thinking we get a shape in. Where would we get the shape in? So we get the shape in like this. Why am I not getting a shape? Oh wait, because I'm connecting the wrong damn thing. It lined up perfectly, but with the wrong thing. So this is the shape of my top left, which is the bottom layer we're looking at. It's a square, which is correct. So the shape needs to come in here. And then it either needs to go into the painting array or bypass the painting array like that. So it's either going to come out here into a painting array or bypass the painting array and get painted. Either way, these two are the output, like that. And we'll do it as close as possible, even if the belting is getting a bit confusing. And that'll be our shape, right? So it's either going to be uncolored, or if it's null, then we just want, well, null doesn't matter, but if it's uncolored, then yeah, because if it's null, there's not even going to be a shape that comes through. So let me just think about this. We just need to test for uncolored. So we just test the color of, if this signal equals uncolored, is that all we're doing? And then we need some sort of belt filtering mechanism. So logic gates equal hard signal uncolored, color U is uncolored. So if it's uncolored, then this red is just, this red is not actually red, right? No, we are doing red. This is the red color. So yeah, we're doing it on the uncolored bypass, but we're testing if the bypass doesn't work. So it goes, is this color uncolored? And it's saying yes, but this color is red. What? Is this coming out the right shape analyzer? It is red. Oh, is this an AND gate? I need an equal gate. Equal, not AND. Equals. Is this color equal to uncolored? No, it's not. Therefore, go out one direction, and then otherwise, if it is uncolored, go out a different direction. So this is the new signal that I need, and I just need some belt control. So if we go to our flow control and we go our belt filter, so we need some belts in and some belts out. So how did we normally do this? So we got 4 belts to deal with. 1, 2, 3, 4. Did we use hoppers? Do we need hoppers? Maybe we, oh yeah, we need hoppers for the signal cable. I've already forgotten how I did my belt thing, but that's fine. So we need hoppers in, and then we need signal in, but then these can't, how did I do this? Oh, what? I need to look at my shape selector. What did I do here? So if a shape comes in, oh, right. It didn't care because it didn't actually, it just stops the shape if it's not the signal that it wants. So this is a little bit of a different design. I was like, why is this hard in my head? Because this actually needs to route in 2 different directions. But didn't I do routing in 2 different directions in my painting array? Yeah, I did, but that's fine. So we'll just make, well, yeah, the whole belt needs to go through 4. So say we've got shapes coming in like that. Then we need to logic gate this. Why don't we then stagger this then? How about that? We'll stagger this a little bit like that. Can we do better? Can this come closer? How much space do I need to do this? Because I need space for this to come out, right? 1, 2, 3, 4. And then I need signal coming in and also belt hopping out as well. Something like that. Then do they need to be staggered? I'll leave them staggered for now and we'll see what we do. But basically I need some belts to go out here like this, and I need some belts. Oh, but then how would I do this input? Do they need to be staggered? Let's ask ourselves that question. What is the implication if they weren't staggered? I would have to give one more room of space. I mean, I have the space. Let's see if I can get them working staggered. How would that input go in? Well, let's get the input in first with these staggered outputs. That would be smart. Then we can route around this input. I don't know why I'm doing this on the least amount of space possible, but yeah, we're here. We're doing it. This seems silly, but we're doing it. Does that seem very silly to you guys? I think it seems silly. I like silly. No, I like efficient, but I like functional first. So let's do functional first, and then we'll talk about efficiency. That should work. It looks a bit like a mess, but now we've got to get the cable in, or the wire, I should say. And the wire is saying no. Bypass. No, thank you. I don't want to be colored. Something like that. It's not clean. I don't like it at all, but for now it works. I'm just going to chuck a bin here. Then we can test whether if we give it like a colored signal, will it be like, yep, that's fine. We'll go through to our coloring array. Is this the top right? This is the top left. It should be a red signal, right? Yeah, it's a red signal. It is already a red signal. And my red signal is not white. So then it should output this out, right? Oh, this is going to my painting array. All right, this path goes to my painting array. So this should be a not signal, right? Oh my God, this is so confusing. Okay, so this signal, no, it's the not of this signal. Oh my God. There we go. There we go. There we go. There we go. Yeah, it's the not of the output result. So if it's not white, then it's going straight through into our bypass, right? It's not going through the painting array. If it is a color, any color, it will go through this side. Then do I need a double not? What? Let me just pull the bin out because I don't think this is working the way I want it to. Hold on one second. I'm confusing myself. But that's okay. It's okay to be confused, guys. We will figure it out. This is going to the bins now. All right. Did I have it right before? Oh man, what is happening to my brain? So this signal is red. Is it equal to white? No. No, it goes in here, right? But I want the opposite effect because no, I want it to go straight through, not the painting array. Wait, no. No, what is happening? Red, not white. It's not equal to white, so I do want it to go into the painting array. And if it is a white signal, so let's put a white signal in. So, okay, it's now white, and then it goes through the bypass. Oh my God, why did that take me so long to figure out? All right, cool. Because I think I confused myself thinking this was not a colored signal. So this is already behaving the way I want it to. Great. Cool. So it is a signal. It's going to go out into the painting array. And then if it is a white signal, if it equals white, it's going to trigger this belt filter to go straight, and straight goes straight into our output. So we do need some extra belts here. We'll jump them over here. Now that'll do. And we just need to belt them out. Should we just keep using belt things until we get closer? Someone told me these are faster than the alternative. So, and we'll get them right back in there. Obviously, you guys can make this a lot more symmetric in a cleanup phase, but I'm not going to waste too much of your time doing that. So then now we have our bypass. This is our shape bypassing thing, so it doesn't get painted. Now this stuff should get painted, but why is it not getting painted? Because that is not where shapes go. It goes up here. Great. Now we should get red squares. Perfect. And that is our painting array done, guys. We need to just hook this back up to this output. Why did I have this all a little bit out? I don't know, but we would have this directly there, something like this. And that's it. We basically just need to duplicate this out 4 times. I'll probably do that in a time lapse because you don't need to see me do that, I guess. But once we've done that, we just need to reform factor this into a nice, more compact version of this, basically. So let me just do that quickly 4 times. Alright, before I even duplicate this, I should probably get my bypass working properly. Let's get this up 3 levels. So this entire bottom section over here needs to go up 1, 2. Just like that. That way it works for 3 levels, and I need this wire also working for 3 levels. Oh, can't see where this wire comes out. Maybe we can, thinking, why don't we get rid of this and this? And get rid of these checks again on these individual levels, and just get the checks happening on the bottom level and send the final output signal up. Wouldn't that be clever? We'll go up to the 2nd level, and then we'll go up to the 3rd level. Oh, that's not how you go up to the 3rd level. We'll go up to the 3rd level like that. That way it should work on all 3 levels, and yep, all 3 levels are now coming out the side to get painted. Alright, cool. We'll copy that over and delete this. Alright, back to the time lapse while I duplicate this out 4 times. Alright guys, I think we are done with our expansion over here to 4 quarters. Now every single quarter gets their own color. Let's just validate all of that's working. I can see that given the shape that we do have a red square coming out here, which is the top left, which is good. And in the bottom right, we have an uncolored bypass going. Excellent. Look at the form factor of this new build. It looks absolutely amazing, and it works. It works. It works. And I think we should definitely collapse it back down over here somewhere and just squish it all in to just minimize our belt usage, and that will definitely speed up our MAM. So let us go and do that. And I'm thinking about whether we can get these belts, instead of having them cross like this. That seems kind of silly now. It seems a bit unnecessary given the form factor of this. So why don't we get the belts coming out the left hand side? I'm going to do all that. We'll probably time lapse all this and then we will continue on. Alright guys, we are back and I think we are done. We have compacted this significantly more. Look how small our MAM is now. It's awesome. I decided against moving the belts over here to come in sideways, because if you imagine, if the belts come in sideways, these painting arrays would have to stack upwards, which would sort of uneven the length of travel for these shapes a lot, because you can imagine one shape would be traveling here, one shape will be here, 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 and your MAM's always going to be slow as your slowest quarter, right? So whatever one that ends up here is going to be way slower than the rest of them. So I decided to do this. In fact, I should probably move it all over a little bit, but the belt length difference between here and the others, I'm not too concerned. This should be okay for now. We can probably shorten this by one tile just to give it a little bit of a helping hand. But yeah, I think we're done. And we are definitely getting the red and this thing out. So we need to get this rehooked up now. So we'll take our recombinator and we will put it over here. And I believe I've maintained all the same everything, so I don't see any issues with it. Let's try to put it as central as possible. And we will get our final belts into this recombinator. Excellent. Cool, everything should be working now, and that is our redesign with the new pipe gate from 0.08. And that's excellent. Our MAM is looking much smaller, so it should perform a lot faster, and it's certainly more efficient. There's no 7 painting arrays for each one and all that shenanigans. I love these new pipe gates. They work fantastically. Excellent. All right, so where do we go from here? I think we will probably call it the end of the episode for this. I know we didn't really get into pins, but we do have a path forward now. With this, we can definitely do a lot more with the pins and the crystals next time. Definitely, I'm thinking maybe we will do a layer of pins for pin shapes, but crystallization, oh, I don't know, that's going to be complicated. So I did notice one thing before we go. These pipes now transport 10.8k liters per minute instead of 7,200 liters per minute, and I wonder why that is, guys. I wonder why that is. It's a very specific number, right? So before, they used to transport 7,200, which is basically 4 full belts worth. If you imagine, like, we used to build for 1,800 liters, right? So each fluid launch is 1,800, so it used to be 4, and that fit perfectly into like a platform entrance. And the 7,200 allowed you to split the belt off 4 times, the way we currently do it. But now it's gone up to 10.8k, and that's a very specific number because that allows you to split the belt off 2 more times. This belt is now carrying 6 inputs worth of fluid now, and why would we possibly need 6 more inputs? I think the game is giving us a little bit of a hint, because if you remember from my Let's Play series, if we bring in a crystallizer, what does a crystallizer take? It takes 2 inputs worth of fluid for each one, which means we can tack off the end of these belts for our crystal maker like this, and that should be enough fluid. Well, assuming we have 6 inputs. I think each of these belts are currently being fed by 4 extractors, so we need to increase that to 6, but it can carry 6 extractors worth of fluid, and it can feed our crystallizers without us having to go out and run 7 new belts. So I think they did that on purpose. I feel like it's too precise to be a coincidence, and that's why you'll also notice I haven't closed off the end of this belt, because I feel like we can continue this fluid belt onwards to do our crystallization, whenever that is. And yeah, that's our new painting array, guys. Nice and simple. I will copy all of this and save it as a blueprint, and then you guys can use that blueprint wherever you like. You can tinker with it, find any bugs I might have left in there, or do whatever you like. So let's save that. We will call this in our, we can save as, we can actually just overwrite our existing thing in MAM. I think this overwrite thing, you gotta be like really careful with it. So this is our dynamic paint selector. We'll save over it, and that is looking fantastic. All right, excellent. I think there's only one more thing I wanted to address before I go, and that's just because everybody seems to, oh, not everybody, I'd say there's a few people that have been commenting about my order of operations, so I'd just like to address that before I go at the end of the episode, in case people didn't come here to listen to maths. But people have been saying basically, why am I bringing a shape in, quartering it, then selecting, creating this spaghetti mess of belts, and then sending it off to painting? Why don't I do it differently? I think one comment mentioned, why don't I pick the shape first, then color it, then quarter it? And they said that way I will save more coloring belts, but that maths didn't make sense in my head. So I'm going to illustrate to you what I'm thinking. So then maybe when you comment back this time, you can explain to me where my logic's broken down. All right. So basically, say you have, this is just to make one quarter, right? So you basically you need 4 belts of shapes in. Imagine these 4 belts are shapes. And you guys asked me, why don't I pick my shape first? So let's assume I have a platform here, and I'll just put a label on it. And on that label, it's like a picker, right? This one is our dynamic selector. So this one, out of these 4 shapes that are uncut, right, will now pick out the correct shape, say circle, and that will come out of here. And then you said, why don't I color that circle first? Or we use the color picker, right? So to make a color picker, then you need what, 7 belts of color. Say you got 7 belts of color coming in here, right? Of those, we use our new color picking array, which is here, and that will pick the color. So now we're picking the color first, and we're picking the shape. So the shape goes in, the color goes in, it goes into some sort of painting array, and then a colored shape comes out of here. Great. And then we determine that is whatever quarter that you need, right? So this is now your quarter shape. So now with 4 input belts of full shapes and 7 input belts worth of fluid, you're getting out 1 quarter. Now you need your other quarters, so you got to do this again, right? And once you quarter it, what I also want to know is, what are you doing with the rest of that shape? So I've picked a circle. Say I need this quarter red square. I've picked the square here. Squares are coming out here. I've picked a red. Red's getting painted onto that square. Now I have a full red square that's getting quartered to get the quarter I want. And then what am I doing? Just disposing of the other 3 quarters of a red square. Then I got to repeat that process for the next quarter, and the next quarter, and the next quarter. So then if you look at the total input for this, I'm still using 4 times 7 belts of fluid for each quarter. And I'm now also using 4 times the amount of input shapes. Whereas my logic is, I take the full shape, I quarter it first to get the 4 input belts of each shape. Then I paint it, then I piece it back together. I don't understand the maths, guys. Like, I feel like I've done this in the most efficient way for input as possible. And other people also suggested, in the old Shapes 1, the way they did it was they brought in 28 belts of shapes. So they would bring in, say this is squares, right? They would bring in 7 belts of squares, color it 1 of each color. So that's like 7, 1, 2, 3, 4, 5, 6, 7, and 8. So they got 8, 1 uncolored square as well. So imagine you got 1 color of every square, and then you get 1 color of every diamond, 1 color of every circle, 1 color of every emerald. That's your starting point for your MAM. So you've got a constant feed of 1 color of every shape. And then it just does logic. It just goes, all right, out of these 28 belts, which 4 of these belts would represent these 4 parts of my shape? And then your MAM becomes super small, but your input becomes absolutely massive. Imagine going around trying to find 8 belts of squares, 8 belts of circles, 8 belts of this, and transporting it all back into a central place, putting it through the painters. And you do still need 4 times 7 belts of color to color all this stuff in, right? So yeah, I'm not sure, guys. I'm not sure. So like, this may not be the best way to do it, but I feel like this is the least amount of input, that this is like the minimum amount of input you can possibly do a MAM with, right? I'm literally doing my entire MAM with 1 belt of each shape and 28 belts of color. And color is easier to find than shapes, is my other reasoning. Like, it's so easy to find RGB everywhere, but finding 4 times more shapes is like kind of hard. So anyway, that's my logic. Take from it what you will. Let me know in the comments if I'm just completely wrong, or I'm just not reading your comments properly. But yeah, I don't get it. I really don't get it. Anyway, thanks for watching. If you enjoyed the video, don't forget to like and sub. Otherwise, I will see you in the next episode. See you guys.